Hello friends, and today we shall be doing Altair tutorial and how to plot various graphs in Altair. Make sure that you have gone through this theory video of Altair, which is the previous one, because it tells you the grammar of Altair which we'll be using, like marks, encoding, and etc. So I'll provide the link of this video in the description box. So let's just first move on to where on our Jupyter notebook. Now, first of all, you have to install this Altair. This is again a Python visualization library. So how do you do that? You go to your search bar and search your Anaconda command prompt. And when it opens, what you do is you go in this installation site and copy this command. I'll provide the link in the description box for this also. You have to write here conda install c conda forge Altair Vega datasets because Altair works on these Vega datasets. So you have to get this Altair datasets, and here you just paste this and enter. It will be installing and updating everything. I have already done this and mine is already been installed, so I'll just close it, but it will ask you a series of like yes and no, so just press yes and your Altair Vega datasets would be installed. So I have this already, that's why I'm not going ahead with this, but this is the way you have to install your Altair Vega dataset. You can also do it in your Anaconda navigation, also creating a separate environment for this. Okay, so now let's move on to creating a new Python 3 notebook. So I will upload this is my working directory where I'm working in my folder data analysis. Therein I will create a new Python 3 and we will work with a data set in Altair, and I would rename this as Altair, and we'll work with Iris dataset today and see how to explore this dataset using Altair. So what I do first of all is I will, after you're done with the installation, you do this import Altair as ALT. Similarly, like we are importing different libraries, we will import Altair also, and then from we will write here Vega datasets. I would import data because in this data I have many data, over 60 data sets are included here, and we just need one. So this Vega datasets, all the data has been imported, and from here I will, what I do is I create an object called iris. In this iris, I will, from this data, I will get iris, okay, and it will be loaded in this container called iris, this object. And now you can check this like simple operations you perform on the data set. This is a simple data set of pandas data frame, like you can compare it and just you can perform all the operations of the pandas here. Iris.head will give you all the first 5 rows and columns. So you can see here the columns and the rows. You want to see the shape of it, just like quickly explore this data and see the shape of this. It's 150 rows and 5 columns here, and I can also see info. So just right here info, just to tell you what are the object types and the null values. So you don't have any null values to deal with, that is good. All 150 values are not null, and the data type is float for sepal length, sepal width, and petal length, petal width, and species is object data type. Okay, so this is what your information is telling you about. Now let's come to our plotting this data. Okay, so I would start with the point chart here. Okay, or I can just say how to draw it in this thing. So I'll just create an object called chart here, and I will write here alt dot chart. Now this is the grammar which I'm specifying, which I talked about in the theory video. And here I will take the data set, that is my iris data frame, and I will write here what is that I want to plot. I want mark as point. Now this is the encoding, and dot encode. So what I'll be doing here is x equals what I'll give here as, like suppose I give here sepal length, okay, sepal length alien, okay, and y I give here as sepal width, And if you want to see it in different colors, so just mention color here so that you will be able to understand what sepal length belongs to which species and which belongs to different one. And here I will also write here chart dot show so that it shows me an Altair Viewer. So you can see here the Setosa, versicolor and virginica. Okay, and this is here and on x-axis sepal length, y-axis sepal width, and you can see that the dimensions for sepal length is from like around 4 point something to 8, and it varies with the various species of iris. So for Setosa, you can see clearly it has been, Setosa is easily classified, identifiable because of its sepal width and sepal length, separable from the other two. Versicolor, virginica are almost overlapping, and you can just find the range from this. But you just see one thing, that this chart has been obtained in a different or separate browser, right? But why not here in my same window? Because I have used here a renderer. Okay, I'll tell you what renderer is. I have not used a simple chart, which I'll show you now. So what is this renderer is that I have now this is a separate this thing. I have again installed this, so you can do this pip install in the same Jupyter notebook, pip install Altair Viewer. What it will do is it will enable you to view your charts in a separate web browser. Okay, so when you install this thing, you will get all these, download all these packages, and you have to write this command alt.renderers.enable Altair Viewer. Don't worry about this thing because it is already there, and I'll provide the link also if you want this. But you don't have to do all these things because it is not needed in Jupyter Notebook. And this I discovered later on, because this is for those non-interactive or non-Python based workbooks which we are working. It works, Altair works very well in Jupyter Notebook, so you don't need this renderer thing here. And when you close this, you just notice this sign that this is still going on, and when you close this just is a normal notebook. Okay, so we don't need this actually. And one more thing if I want to tell you is that if I just want to save this simple what I have created, this picture, what I will do is chart dot save. I can just write, and what I'll give is the name I would give. I'll give like iris dot chart dot html. That is how I want to save it. And you want to see this where it is, then you just go back to your folder and you just scroll down and you can see iris being created, iris.html being created. Okay, and you see this file here, iris.html. Okay, right. So now we come to another thing, and that is I'm gonna show you one more thing here, and that is ticks. Okay, but before that, just bear with me a little. Okay, I'll just simple write here alt.chart, and but remember one thing, that the C is always capital here. This is the grammar, and then I want this iris simple, the data set I have, and then mark underscore tick. The way I want to represent my data is as tick, and I want to encode my data, and in this encoding what I want is I want X as suppose pedal length. Okay, and I would also give color so that I can understand which species has what petal length. So I'll just write here species, and let's see this. Okay, so now you see that we are getting the output here itself. Okay, we do not need a local host, a separate web browser for this, but this was just additional information if you're not working with Jupyter Notebook or any Python based IDE. Okay, so as you can see in this tick, that the petal length for Setosa is somewhere around 1.02, less than 2, and for versicolor it is like from 3 to 4.5 or so, and we get a mix from virginica from like 4.5 to 7. Okay, so we get a little mix in versicolor and virginica and petal length, but this setosa is easily identifiable species. Now if you want to see this iris, if you're working first time for this iris, so I'll just show you this iris data set images. So you just see this iris versicolor, setosa and virginica. So the setosa is, you can see, very small and easily identified with the dimensions also we have seen, and this versicolor is really big. It has got the sepal length, you can see, and the sepal width, the petal length and the petal width, right? And this is virginica. So we can identify because we are humans, but we want machines to identify these species of iris, you know, separately, given petal length, petal width and sepal length and sepal width. Okay, so now we come back to our data set, and again, if you want to experiment with this thing, you can just change here with, you can play around with sepal length, petal length and sepal length, sepal width. So just see the sepal length. See, sepal length is quite mixed, so this really is confusing because you cannot identify this feature, this species with sepal length. Petal length was more good measure. What about if I write here petal width? So I'm just exploring the data with the figures. So petal width is also good differentiation. It is providing for various species, and likewise you can experiment with different columns here, mentioning here x, and we can find how is it being differentiated from each other. Okay, now now we will move on to line. Let me show you how does this line works here. So I will be working with a line plot or a line chart. Okay, so I'll write here alt dot again chart. So in this alt dot chart, what I will write, my dataset iris, and what is the type I want is mark line. Now I'm giving the encoding, specifying it, and dot encode. What I want to encode, I want to encode on x-axis. Let's take petal length. Okay, and on y-axis, let me take petal width. Let's see these two dimensions, how do they work. And I'm just plotting a simple graph, and here I will take species. Okay, let's see how this works. Petal length encoding, because does not match the column. Okay, I must have given a wrong spelling. Yes, that's what I always do. Okay, THHT, please bear with me because I am like spelling mistakes. Okay, so now what you get is the petal length, petal width and various species and how they are being plotted in this line plot. So easily identifiable, all these species. Now suppose if I just play around with sepal length and petal length, I will just copy this and let me paste it here, and instead of this I simply change this into sepal length and sepal width. See guys, we have just 4 features to play around with, and this color is giving it the third dimension, that is species. So we can just play around with these 4 and 5 columns only. So now you get this sepal length and sepal width. Okay, I can just zoom in to show you what it means. Now you can see this setosa again can be identified, but we have a problem when it comes to versicolor and virginica, because they have got almost same dimensions of, you know, sepal length and sepal width. But here when you specify this thing, and you see here that the petal length and petal width are a real good measures if we take these features, which can easily identify setosa, versicolor and virginica. Okay, and we know this petal length is this inside. Okay, so this can really help us understand which species of iris is what. Okay. Okay. So now let's move on to bar chart. So I'll just go on to bar chart, and again what I do is I think I have shown you point charts. First let's just take bar now. What I'll do is I will simply write point dot bar, but I want to show you something good here, like al2 alt dot chart. Again I will write here. I think yes, and again write the same thing, iris, and I think by now you would start remembering all these things also. Dot bar, and simply dot write dot encode, and again what we will encode is x equals, okay, I am showing you something interesting here now, just wait and watch. X, and here I will give you petal length. Sorry, this is not like this, petal length, and let me give you the bin as, because I'm using tagged bar here to show you different bins equals 30, and next I will do is y, and in y what I'll do is I want count of these petal length, and in color I would simply write what species, because that is how your data would be more meaningful. Okay, so this is what I got. This is what I am getting as my chart of bar. I have specified bins here. So this is a bin histogram, as you can see, and I'm getting the count of records for sepal length, petal length of Setosa, versicolor, and virginica. Okay, now you can see here that few of these species of versicolor and virginica have mixed dimensions ranging from 4.2 to 4.6, and from 4 point something like 8 or so to 5 or so, right? So I can just see that what are the mixed dimensions here. Okay, and I can change the dimensions to see the various bins here. Okay, so this was not a, this was a stacked bar chart rather than a simple bar chart. Okay, so now let's move on to a different type of a chart. Let me show you point. Let me show you the point chart. Alt dot, make sure C is capital because I make this mistake, and this is here iris, and dot, again what markers I want point, and again dot encode, just write it down, keep writing, and in X suppose I take petal length, and let's in Y take, see it is not important that you have to mention it in space bar, you can write here also, like Y equals to, let's take sepal length. Okay, two dimensions, different features, and I write color equals, again, species. Okay, all right, let's see. And another thing is that I was mentioning all these things like x and y, and like this, just to make it more representative, that's all, to make it look more clean. Otherwise you can just mention it, the code into a one simple line, right? So you can see here the point, this is clearly mentioning these points, and now you can see these point markers, and this is what the legend I would see here. It is not a color bar that we get in Plotly, it is a simple legend specifying marks which can easily identify your data, and you can easily identify these categorical data with these. So this is inbuilt, this is intuitive, it is already taking it for its own knowledge and plotting my data as per the values I give, because the Panda data frame, if you're working with it, Altair automatically identifies the data type and work with that. Okay, so here we have this Now you can infer this thing, that petal length and sepal length for setosa and versicolor and virginica and so on. Now another thing is that point bar, and there's something also called, now I walk you through one more thing, and that is rectangle. Let us just check out this rectangle. Again, I will write here chart and mention this iris dot mark. You have to write the same things again and again, and you don't have to worry about much because it is almost the same graphics grammar which is it is using, just a little change of encoding here and there. And you can just take here like petal length, sepal length, and y could be, okay, let's take sepal width, and the color could be species. Okay, let's, this is a rectangle, right? So I can just give here, let's see, oh no, oh no, this is not, this is, I am not getting anything for versicolor. Where is it? It is hidden. And what if I give here, let's see, I give here count. Okay, I just want to see the count of sepal length and sepal width and the count of records. So in rectangle it is just showing me the count of records here, and I am not able to decipher this thing, what is this, because of my data set. Okay, and if I take here species, let's see. Okay, quite fine. This is fine. So let's like the sepal length and sepal width, the range is being given here, and setosa. Rather, let's just change the dimensions x and y and see what are we getting. And what we get is something like this. Oh my god, no, I think the previous version was better. So this is x and y. Yeah, okay, got it. Fine. Now again, I want to show you some more thing here. Let's just move on to an encoding thing, which I want to tell you about the concatenation. Concatenation. How do you do this concatenation? Pardon me for the spelling mistakes or so. If it is there, just walk in through like base. I will just write here. I make an object called base here, and I write here alt.chart, and in that I give iris dot, again the same thing, repeat, dot mark, and I'm using point here because this is really good representation for this iris data set. And then I write here encode, and then I write here x equals, let's take here petal width, okay, and on y I will take here petal length. All right, and again the same thing repeats, color equals to species. I think you can master this coding. This is so easy, really, guys. Base, and I have to mention here like base dot encode, and this is the grammar again, its own set of rules and how it will work because it is being encoded like this. And here I give here sepal width. All right, let's see what it does. Dun, dun. Okay, now you just see this thing, the petal length versus petal width, petal length versus sepal width, and it has been concatenated like this. And this is a horizontal concatenation, guys. Okay, so first dimensions x and y being encoded with petal length and petal width, just like I mentioned. In the third one, the concatenation which I wanted in the second graph, I got sepal width, petal length, and sepal width. Okay, so this is how it has been encoded with y, and then in x I got sepal width. I can mention here y also. Okay, and here then I will get petal width. Okay, let's just try this. and this is how the dimensions changes. You can play around with x and y, and you can get different charts here. This was about horizontal concatenation, and now let's move on to a different concatenation, and that is vertical concatenation. Now suppose I don't want my charts to be shown like this. I don't want them to be shown like this. I want them to be shown one below the other. So I want a vertical concatenation. So what I do is I would write here simply base and, not this end, this and base dot encode what I want to encode, and y equals to, again I can just mention here like sepal width or petal width or whatever you want to mention, and right here. Okay, so now I'm getting it in vertical concatenation form. Okay, this is petal length, petal width, and this is sepal length and petal width. This is horizontal and vertical concatenation. And this was about bar chart. We've got seen mark point, ticks, and line chart here. We've got also area in rectangles, squares in this encoding part, and you can try this in Iris dataset. I will be providing the link for the displaying, installation, and also the documentation of Altair, which will walk you through various datasets. And it will be a good practice if you can just explore these datasets of Altair and practice it for yourself. It is quite easy to write. This grammar is very easy, and I found it really interesting to work with. Try this data visualization library in Python and see for yourself how does it really work. You've got various confidence interval levels and confidence various statistical tools also, which you can plot here. Okay, and in coming up videos I will be showing you how to really plot and with these or work with these statistical information, work and plot these statistical information to represent your data. So this was all about the Altair dataset. I have also done this CARS dataset. If you want this CARS dataset, I can come up with this CARS dataset. So just mention in the comment section if you want this CARS dataset. I can make a video on that too. So stay tuned guys, and thanks for watching.